In the previous video, we have started with the very first chapter of Maths Part 2, that is complex number. In that complex number, we have seen how complex number can be formed. Right? Complex number is actually combination of or composition of two numbers, that is real part and imaginary part. If you connect any real number with I, so that number becomes imaginary number, and if you add any real part with that number, so it becomes a composition of real number and imaginary number, so that composition is known as complex number. We have seen different types of complex number, as well as we have seen the algebra of complex number, where we have seen how to add, how to subtract, how to multiply, and how to divide two complex number. If you add, if you subtract, multiply or divide any two complex number, the result is always a complex number. After that, we have seen the exercise first of this chapter. In that exercise, we have seen how the different kind of complex number can be converted in the standard form of complex number, that is a plus ib, right? So we'll continue with the same exercise, that is 1.1, and we'll see new example and new different type of example in this exercise. Okay, so let's start with the complex number exercise 1.1. Okay, so exercise 1.1 we are going to start. We have already taken few examples from that, so now we will continue with the same exercise. Example is, express the following in the form of a plus n. So we have to convert the given expression in the standard form of complex number, that is a plus I. So let's see what is the expression given. Expression is 3 plus 2i divided by 2 minus 5i plus 3 minus 2i divided by 2 plus 5i. 3 plus 2i divided by 2 minus 5i plus 3 minus 2i divided by 2 plus 5i. There are two fractions. In that fraction, there are 4 complex numbers, and we have to convert that in the form of a plus I. So we want only one complex number as their result, right? So how to do that? See, when your denominator is not same, so first we try to make our denominator same by taking LCM. Or if you are getting confused in taking LCM, you can simply take cross multiplication. Okay, that is also fine. So if you take cross multiplication, so 3 plus 2i will multiply with this, so you will get 3 plus 2i into 2 plus 5i. Right, plus and add. Then take 3 minus 2i multiply with 2 minus 5i. Right. Okay. Now, denominator multiply with denominator, so we will get 2 minus 5i into 2 plus 5i. Like this, we can take cross multiplication of these two fractions. Okay. Now, these two brackets we can simplify. These two brackets are this is multiplication of two complex numbers, right? If you multiply into two complex numbers, the result is always a complex number. So multiply this. 3 into 2 is 6. 3 into 5 is 59. 2i into 2 is 4i plus 2 into 5 is 10i square. Okay, this is first expression. Plus similarly multiply these two. 3 into 2 is 6. 3 into 5 is 59. Minus 2 into 2 is minus 4i and minus plus 10i square. So this is how we have multiplied numerators 4 bracket. Now denominator is 2 minus 5i 2 plus 5i. This is in the form of a minus b, a plus b. So when you have a minus b, a plus b, that is nothing but a square minus b square. So your a is 2, so a square minus b square into 5i square. This is how we can multiply denominators bracket. Now we simplify this. have here? 6 plus 59 plus 4i plus 10i square. 59 plus 4i we can add, we get 99 here. And this 10 into I square. But we know I square is nothing but minus 1. So what do we get here? Minus 1 into 10 is minus 10. So 6 minus 10. 6 minus 10 is minus 4. Right? And 59 plus 4i is 99. Okay, this is simplification of first bracket. Similarly, the second bracket. Second is 6. Now similarly 10 I square. Again I square is minus 1. Minus 1 into 10 is minus 10. So 6 minus 10 is minus 4. And this minus 15 minus 4i becomes minus 19i. Okay. Now come to denominator. Now denominator when we have 2 square, that is 4. Right? Minus sign as it is. 5 square is 25. See, this square is applicable for 5 and I both. So here you are getting I square also. But value of I square that you know that is minus 1. So that minus and this minus become plus. So it is plus 25. Okay, this is your denominator. Now simplify the numerator. This minus 4 become minus 8 because we are adding these two. This 99 and this minus 99. 99 and 99 will cancel out. So what you will get? You will get 4 plus 25 which is 29. So you get minus 8 upon 29. This is real part only, but here we are not getting any imaginary part. But in the question they ask you to convert the given expression in the form of a plus ib. We are getting only real part. But what about the imaginary part? So whenever you don't have imaginary part here, you can consider imaginary part as 0i. So this is the standard form of complex number, that is a plus ib. Okay, so your a is minus 8 by 29 and ib you can consider as 0i. Okay, this is how you can convert the expression in the form of a plus ib. Okay, sometimes you get only imaginary part, sometimes you get only real part. So whenever you get only imaginary part, you can take 0 as their real part, and when you get only real part, you can consider 0i as their imaginary part. So this is how we can convert it. Okay. अगोदर सांगा सर. Okay, student. So we'll take next example of same kind. Okay. The example is show that minus 1 plus root 3 r cube is a real number. Is a real number. We have to show this number minus 1 plus root 3 r cube is a real number. Okay. So how to check whether it is real number or not? Because the given number is a complex number, because it is in the form of a plus ib. You can see that real and imaginary both parts are there. So how we can convert that number into real number? Because they said it is a real number, so we have to prove that anyhow. So let's see. But before we do this, which formula we can use here so that we can convert this into this complex number into more simplified form? The given expression is in the form of a plus b bracket cube in that form, right? So can we use that formula here to convert that into simplified form? What is a plus b bracket cube formula? A cube plus 3 times a square b plus 3 times ab square plus b cube. This is our ideal formula of a plus b bracket, right? So here we'll take a value. What is the value of a? That is minus 1, and value of b, that is root 3i. We have to consider the whole root 3i as a b. Okay. Now use this formula a cube. Now we have to take minus 1 cube plus 3 times a square is minus 1 square and b is root 3i plus 3 times a is minus 1, b is root 3i and their square, and b cube is root 3i cube, like this. Okay. Now simplify this minus 1 cube. When you have odd number as a power, that minus 1 left as it is, that minus 1 plus. Now 3 times minus 1 square is 1 into 3 is 3 and root 3i as it is, because they are in multiplication form. then plus this 3 minus 1 is minus 3, root 3 ka square is 3 and square of I is I square, like this. Okay, 3 into minus 1 we have taken minus 3, root 3 square is 3 and I square added plus root 3 ka cube, that is 3 times root 3, and this I cube also we have to consider. Okay, because that cube is applicable for root 3 as well as I. So minus 1 as it is plus 3 times root 3 I, then this square of I square ka value is minus 1 and this minus becomes plus, and 3 into 3 is 9. Then this I cube, we know value of I square is minus 1, but we have I cube, so if you multiply here I on both sides like this, so you get minus I here. So value of I cube you are getting minus I. So this plus become minus because of this value 3 root 3 I, like this. So value of 3 root 3 I cube is minus 3 root 3 I, right? So positive 3 root 3 I and negative 3 root 3 I can cancel out. So what you get? Minus 1 plus 9. So you get 8, and 8 is nothing but the real number. Okay, the real number. Okay, so this is what they asked to show that this number is a real number. So we got our answer 8. We don't have any imaginary part here, so we can say 8 of this number is a real number. Okay. Now let's see the next example. Show that one more number is there, 1 plus I to the power 10 plus I to the power 20 plus I to the power 30 is a real number. Is a real number. This is what they asked to show. 1 plus I raised to 10, I to the power 20 plus I to the power 30 is a real number. Okay. So what we will do, we know one thing, that I square ka value is always minus 1. Correct? So what we will do, this I to the power 10, how we can write that? I to the power 10. Can we write that in the form of I square and their power 5, right? And I square ka value that we know minus 1. So this is in the form of minus 1 to the power 5. When you have power as an odd number, that minus 1 becomes minus 1. So minus 1 to the power 5 is nothing but minus 1. Right? So indirectly value of I raised to 10 is minus 1. Now come to the next, I to the power 20. How you can write this? I square and then 10 power, because 2 into 10 is again 20. I square ka value we know that is minus 1 and their power is 10. When you have power even number, that minus 1 become plus 1. So minus 1 to the power 10 becomes 1. Right? So indirectly I to the power 20 ka value becomes 1. Now similarly I30, how you can write that? I30 we can write I square and their power 15. Right? So value of I square that is minus 1 and their power is 15. 15 is odd number, right? So minus 1 to the power 15 becomes minus 1. Right? So indirectly I30 ka value is minus 1. Now I raised to 10, I raised to 20, I raised to 30, all these three values will be put here. Value of I raised to 10 is minus 1, value of I raised to 20 is 1, value of I raised to 30 is minus 1. So all these three values will put in this expression and we'll see what we get. So write the first term 1 as it is, then I raised to 10 ka value we got minus 1, I raised to 20 ka value we got 1, and I raised to 30 ka value is minus 1. Okay? So this minus 1 and plus 1 we can cancel out. So what we get? 1 minus 1, that is 0. Right? So 0 is real number. We don't have any imaginary part either. So we can conclude 0 is real number. So this whole expression is a real number. Okay?